Okay, students, we will start the chapter number 13, magnetic effects of electric current. So as we previous chapter, we discussed the electricity. In this also we have studied that heating effect as well as chemical effect of electric current. Now in the present chapter, we shall study the magnetic effect of electric current. So here you can be observed that this figure here, we take the one cardboard paper, make the one hole at the center of the cardboard paper and pass the one conducting wire, that is copper wire or aluminum wire. Now both the ends of this copper wire are connected with the resistors, emitter as well as battery and simple key. Now you should be kept the one magnet needle on the cardboard paper near the rod. Now switch is on. So current will be flow from positive terminal to negative terminal. So at that time you observe the magnetic needle. So you observe this show that the magnetic needle will be deflected. It means that when current will be flow in a conductor, magnetic field is produced around this conductor. Now during the 18th century, a science teacher H.C. Ørsted discovered the magnetic field is produced by the electric current, and other scientists like Michael Faraday and Andre Ampere had produced electric current from the magnetic field. Now here we discuss about the electromagnetic or electrodynamic. So this is the branch of physics that covers universal study of electricity and magnetism, is called electromagnetic or electrodynamic. And these electromagnetic principles are widely used in the loudspeaker, electric motor, maglev train, hard disk of computer, communication, etc. Now we'll study the magnetic field and magnetic field lines. Now students, you have seen a bar magnet in the laboratory. You have studied about it in the standard 8. A bar magnet has two magnetic poles, north pole and south pole. Now this bar magnet is suspended freely through the string. The pole which becomes steady towards the north pole of earth, it is called the north pole of magnet, and other pole is called south pole. Now a repulsive force is resulted on bringing north pole and north pole, or south pole, that is like poles of two different magnets near to each other, while attractive force is produced between the north pole and south pole, that is opposite pole, or south pole and north pole. So magnetism of magnet is maximum at their poles, and the magnetic force is represented by the magnetic field. Now here we shall study the characteristics of the magnetic field lines. First characteristics of this magnetic field lines is like that the magnetic field lines of magnet start from north pole to south pole. Okay, and they form closed loop. Second characteristics, the region in which the field lines are at close distance to each other, a strong magnetic field. It means near the poles of magnet, the field lines are at close distance from each other, so there is a strong magnetic field. And third characteristics, the magnetic field is a vector quantity, so it has a magnitude as well as direction both. And fourth characteristics, the magnetic field lines do not intersect each other. So these are the characteristics of magnetic field lines. Now here, next one, we should study the activity 13.3 here in your textbook. So for this activity you need a bar magnet, magnetic needle, white paper, drawing board and pencil. So first one, you place the whiteboard paper, then put the magnet in the center and mark its position with the pencil. Now place the magnetic needle near the north pole of magnet. You will see that its south pole will be in the direction of magnetic north pole and north pole of magnetic needle will be in the outward direction from the magnet. Now arrange the magnetic needle such that south pole of needle is arranged on point B here. Okay. So mark the position of north pole of magnet needle up to the south pole of magnet by arranging it at the position one after the other. And last one, you draw the curve joining all these points, and this curve shows the magnetic field lines of a magnet, and these magnetic field lines show a magnetic field around the magnet. Now next one we'll discuss about the magnetic field, the current carrying conductor. So here we take for that you take the long straight copper wire and arrange both the wire that is connected with the battery and simple key in a series. Now place the straight wire parallel to and over a compass needle. Now switch on the simple key. So will be observe that the current will be flow from positive terminal to negative terminal, and you will show the deflection in the compass needle here. Now in opposite direction, okay, you change the battery, that is positive terminal to negative terminal, due to polarity will be change of the battery and connected as previously, that is battery and simple key in a series connection, but the polarity will be changed. So you will show in a magnet needle the north pole move towards the west direction. It means that here the current will be changed, the polarity of battery will be changed, the direction of magnet needle is also changed. It means that the deflection in the needle becomes opposite when the direction of current is reversed. Now magnetic field due to a current through a straight conductor. So for that here you make the hole in the center of the cardboard paper and pass the conducting wire through it. Connect the battery, simple key, ammeter and variable resistance as shown in figure in a series connection. Now switch is on, that is pass the electric current through the wire by placing the key. So you will see that the iron flings, first you should be kept the iron dust or iron flings on the cardboard paper uniformly, and when the current is flow you have tapped the 2 or 3 times with the fingers. So when current will be flow through this conductor, you will be observe that the iron flings get arranged in concentric circular shape like that. Okay, and this circular pattern represents the magnetic field resulting from an electric current through the wire. If you know the direction of the electric current, if you know the direction of magnetic field, place the magnetic needle near the some point at the point P. The direction in which the north pole of magnetic needle points indicates the direction of magnetic field lines. Now on reversing the direction of electric current, so you will be see that the direction of needle placed at point P is also get reversed. So from this activity, that is HC Orsted conclude that the magnetic field is directly proportional to the electric current, and magnetic field decreases inversely at distance while moving away from the conducting wire.